Hello friends, in this video we will do deletion in a tree. The other algorithms for insertion and traversal I have discussed in a previous video. What is a binary tree and how it is represented inside the computer, that is also discussed in previous videos. So you can refer to them and then come back to this video. So let us begin with the deletion. When we want to delete the node in a tree, there are two steps in deletion. First is we have to find the node in the tree that we want to delete, and after we have found the node that we want to delete, there are four cases. One case is the node does not have any child, then it has one left child, one right child, or it has both the children. So as we can see here in the diagram, in this node A does not have any of the childs and it is only one node in the tree. In this case, we will simply set the root to null and free the pointer of A. Then in case when it has a single left child, like A has a left child B, so what we will do here is we will simply, and we want to delete A, what we are going to do is we will replace A by B. Similarly, if it has a right child A and C, C is the right child of A, we will simply replace A by C, and some pointer modifications are required, which I will be discussing shortly. Then if it has both the children B and C, then you have to fix this logic in your code. Either the right or the left child will always replace A. So if I fix the code to that the smallest value in my right subtree is going to replace A, then C will replace in this case. And if we look at this larger diagram, in this we have A has a child C, which has a left child D, which further has a left child F. Then this left child F is going to replace A, which is in the right tree, the smallest value will replace A. If you are looking at this ABCD as a incremental values, these are just notations, and we are going to perform this deletion in a binary search tree. So please treat it accordingly. So as we can see here on the screen, the algorithm for the delete from binary search tree is given. In this, we have taken two pointers. We are receiving as input the start pointer or the root pointer of the tree and the data that we want to delete. So first of all, we have to find the location of the data in the tree. So how we will do it? First of all, we will store the root in the temporary so that the root does not get modified. And we will also initialize the PPTR pointer, which will always point to the parent of the temp. Why we need this? If I want to delete a node A, then I have to modify the value in the parent of A. So therefore, I need the parent of A if I want to delete A. So for this, we are maintaining the PPTR pointer. So again, in a while loop, while temp will not be equal to null, we are going to iterate and we are going to find out if the data that we want to delete is equal to the temporary's information, will break. Otherwise, we will go to the left or the right accordingly, as we are doing in a binary search tree. And we are updating the PPTR to temp and whatever was the old value. So this should come up actually. First, we will store the previous value of temp in PPTR, and then we are going to update the temp to pointing towards the left or the right, depending on what is its relation with the data. This is simply like a search in a binary search tree. So we have, after we come out of this loop, there are two cases. One case is that the node is not found. In case the node is not found and the temp is equal to null, we will simply say that there is no such data in the tree, so we cannot delete. So otherwise, we will have a pointer in temp and the PPTR will contain the pointer towards the parent of the temp. Now what we have to do is we have to check whether this node has no child, it has one left child, right child, like that. So for that, we will first of all match the data with the temp information. Then we will check if temp left is null and right is also null. In that case, if temp is the start of the tree, then simply set the start to null. Otherwise, what we are going to do is, if the data is less than the PPTR info, then the left pointer of the parent is going to be modified to null. Otherwise, the right pointer of the parent is going to be modified to null. Similarly, we will do for the, if the tree will have a left child, what we will do is, we will promote the left child of the tree to upgrade to the right or the left of the parent pointer, depending on what is the relation of the temp with the parent pointer's information. If the temp is on the right side or if the temp is on the left side, depending on that we are going to compare the information. Then similarly we will do for the right child. So we will compare here that if the node to del is temp, then if it has a left information, if that is less than the PPTR info, then we are going to make the this one is the right child, so we will compare the right temp right, and if the right child's information is less than is greater than that of the parent pointer, then we will set the right child of temp as the new temp instead of the old temp. The new right child will take the place of the node. Then if both the left and the right child both are present, in that case what we will do, we will find the minimum in the right subtree and we will replace that minimum value into the temp, and then we will recall this delete VST logic for the temp right and for deletion of the data which we have copied into the temp. So for that particular information we will recall in the right subtree that node should be deleted because it has been promoted to the level of the temp. And how we are finding the minimum in the right subtree? We are simply going to the left of the right node and we will go to the leftmost node of the right subtree. Now let us look at the coding for this particular deletion process. So as you can see here, we have already created a node structure for the tree. Then the logic for insert, as I have already discussed in a previous video, is given here. Then the find min, in which we are finding the leftmost child of the right subtree. So we are passing the pointer of the root or the node from where we want to find the of the right subtree. And then if that pointer is null, we will simply say that there is no such leftmost child of the right subtree. Otherwise, we will update the pointer to the left child, and if it is not equal to null, then pointer will traverse repeatedly towards the left in order to find the leftmost child of the right subtree. And here we have the logic for the delete VST. So in delete VST, first of all we are checking that there are nodes in the tree. So start if it is equal to null, then the tree is empty. Then we have the logic for the search, in which we are finding the parent pointer and the pointer towards the next node or the temp node. Instead of temp, I am using PTR here. And then we have the logic for the node child. Then we have the logic for the left child, and the first of all we have the logic for that the start itself is the node to get deleted. Then we have the logic for node child. Then we have the logic for left child is present. Then we have the logic for the right child is present, and then we have the logic for the whole subtree is present. Both the left and the right childs are present. In that case, we will take the minimum from the right subtree, and then we will update the information in the pointer, and we will delete that information from the right subtree of the tree. And when we are calling this is the in order and the pre-order traversal. Now we are calling an insert in the tree. So first of all we are creating 10. 10 will have a left child 5, which will have a right child 7, and 5 will have a left child of 1, and then 17 will become the right child of 10, 11 will be the left child of 70, and then 18 will be the right child of 17. We will print the in order traversal of this particular tree, and then we will delete the root, that is 10, and using this logic which I have just discussed, and then we will print the in order traversal. So let us see what kind of an output will appear. So first of all, we will have an output from this in order, which will display all these nodes in a proper sorted order. And then we will call the delete PST, and after that, and again the in order traversal will be there, but 10 will be missing from the data. So let us execute this, compile and run. So as we can see here, first of all 1, 5, 7, 10, 11, 17 and 18 are there. Then the call to the deletion is made, and then 1, 5, 7, 11, 17 and 18 is there. The 10 has been deleted from the tree. I hope this video is useful to you. If you like my channel, subscribe to the channel, and you can refer my videos to your friends also. So thank you very much for watching.